Hello, in this video I will do 5-question quiz on ordinary differential equation and initial value problems. So this is a quiz on ordinary differential equations. So number 1 says, so on 1 through C, 1 through, or 1 through D, the direction says, give the order and state whether the ordinary differential equation is linear or nonlinear. So we got to state the order and determine if it's linear or nonlinear. So on A, we look at the highest derivatives. So this is second, this is third, this is no derivatives. So the highest order is third. Is this not linear or nonlinear? So what we have to do is look at the variable. So this one, variable in front of the, or the coefficient in front of the derivative. So this one's fine because this has a coefficient of 1. As long as it doesn't have a y on it, that's fine. This one, no. Why? Because this has a coefficient of 2y. It cannot have the same letter on the top, so there's can't be no y's. So that automatically makes it nonlinear. Okay. B, what's the order and is this linear? So the highest derivative would be this one, second derivative, so that would be second order. Now, is this linear or nonlinear? Well, this is fine, right? This has a coefficient 1. This is not fine. You have a sign, even though it doesn't have a y, but you have a y variable, but is attached to a trig function. So you have a y variable attached to a trig function. Okay, so this sign makes it nonlinear. Okay, C. What's the highest derivative? I would say the second. This d squared, dt squared, that's second derivative. So it's going to be second order. Is this linear or nonlinear? Let's look at the first term. This has a t, does not have a y, so you're good. This one is fine because it has a t square, right? As long as it doesn't have a y in it, you're fine. This one, y prime is the same thing, dy dt, right? Y prime is the same thing, dy dt, and it has a 2. So as long as it doesn't have a y in it, you're fine. What about this one? Yes, it's fine because if it was in a y, this would make it nonlinear. So this is fine. So you could say this is linear. Okay, D, we have what would be our highest order? It would be, the highest order would be fourth order. This is fourth derivative, this is third, second, etc. So the highest order would be fourth order. And is this a linear or not? So this has a coefficient of 1, so that check mark. This has a coefficient of 1, check mark. This has a coefficient of 1, yes. This has a coefficient of 1, yes. This has a coefficient of 1, so yes. This is a constant, so constants are fine. So this means that is linear. Okay, so let's move on to number 2. It says verify each given function is a solution of a differential equation. So this is like initial value problem. So we have y, for number 2, we have y equals c times e raised to the 2x, and we have y prime equals to 2y. So we got to verify that each of the given function is a solution of the differential, or the left equals to the right. So first, what I would do is find the first derivative, because we do need y prime. So we have y. You have y equals c e to the 2x. Let's find the first derivative. That would be, so c is a constant, so you could just take it out. All you got to do is take the derivative to e to the 2x, and that is c. And what's the derivative of e to the 2x? It's just e to the 2x times the derivative of the power, which is 2. That is y prime equals 2c e to the 2x. Okay, now let's put it in here. So y prime, we said y prime is 2c e to the 2x equals 2 times y, which is c e to the 2x. So when you put it all together, it says 2c e to the 2x, and then this is 2c e to the 2x. So the left does equal to the right, so we just verified. So yes, the left equals to the right. Okay, let's move on to number B. So we have y equals c1 e to the 2x plus c2x plus 2 over x, and then we have all of this. Oops. So we have all this. So we got to verify. So we need what we'll need is we need to find the derivatives. So we need the second derivative, the first derivative, etc. So let's see what we have here. Okay, so we have y equals that. So first, I'm going to find derivatives. So first, maybe I would do is, do you see this 2 over x? I'm going to rewrite it as a negative power sign. I'm going to rewrite y equals c1 e to the x plus c2x plus 2 over x is the same thing as 2x to the negative 1, right? So what I need is first derivative and second derivative. So let's find first derivative. So the derivative of c1 e to the x is c1 e to the x. The derivative of c2x is just c2. The derivative of 2x to the negative 1 is negative 2x to the negative 2. Okay. I'm going to circle it because I'm probably going to have to plug it back in. That's not our answer. I just want to box it. And then my second derivative is the derivative of c1 e to the x is c1 e to the x. The derivative of c2 is a constant, so that's 0. And then the derivative of negative 2x to the negative 2 is positive 4x to the negative 3, right? Let me box it because we're going to need that, right? So now if you look at our problem, we have 1 minus x times y double prime plus xy prime minus y equals 4, all that. So we have everything we need. We just got to plug it in, right? You have everything we need. So it's going to be 1 minus x times y double primes, and I kind of boxed it, so I already have it. So y double prime is c1 e to the x plus 4x to the negative 3 right? Plus x times y prime. Y prime is c1 e to the x plus c2 minus 2x to the negative 2 minus y, regular y is c1 e to the x plus c2x plus 2x to the negative 1. So let me put that in. Equals 4 1 minus x squared times x to the negative 3. Okay, so all we got to do is clean this up, and then once the left equals to the right, you verified it, right? It's a lot of mess, but you just have to FOIL it out, be careful, and collect like terms. So let's do this part here. So go ahead and FOIL this out. So 1 times C1 e to the x is C1 e to the x. 1 times 4x cubed is 4x to the negative 3. Negative x times C1x is negative C1x e to the x. Negative x times 4x cubed is negative 4x to the negative 2. Now, do this part. FOIL this out. This would be x times C1 EX is C1 x e to the x. X times C2 is x C2. X times negative 2x, that would be negative 2x. And then when you're multiplying with the same base, you add. So negative 2 plus 1 is negative 1. And then FOIL out, do this part. So FOIL out this minus. So this would be negative C1 e to the x minus C2x minus 2x to the negative 1. And then all you got to do is collect like terms. Cancel as much as you can, and maybe hopefully the left side equals to the right. So what do you see that cancels? So I see that this C1x cancels this negative C1 e to the x, and then this negative C1x e to the x also cancels with this C1x to the ex. And then this x C2 cancels with this so okay, so this 4x cubed, this C1 x e to the x. This, okay, so this stays here, this stays here, this stays here, this cancels, and then this stays the same. And then on the left side, you're just left with 4x to the negative 3 minus 4x to the negative 2. These are what hasn't canceled. minus 4x to the negative 1, right? And then on the right side, I forgot to FOIL this out. If you FOIL this out, this would be 4x to the negative 3 times 1 minus x squared. So this is going to be 4x to the negative 3 minus 4x to the negative 2 minus 4x to the negative 1. So now the left does equal to the right. Okay, so you can say this is true. We just verified it. Okay, so that was B. Now let's do 3. So verify the function is a solution of the initial value problem where y equals x times cosine of x, y prime equals cosine of x minus y tan of x, and then you have a coordinate of y of pi fourth equals to pi over 4 over radical 2. So what to do? So we have a coordinate right here. So this is pi over 4 comma pi over 4 radical 2, right? We do have a coordinate. So what I'm going to do is find the derivative. So we have y equals x cosine of x. So how do we find the derivative of that? We have to apply the product rule. So this is your f, this is your g. The product rule is f prime of g plus g prime of f, right? So it's going to be y prime, f prime. So my f is x, and my g is cosine of x. So f prime is 1, g prime is negative sine of x. Okay, so f prime is 1 minus g, which is cosine of x, plus g prime, which is negative sine of x, times f, which is x. 1 times cosine x is cosine x. This, I guess you can put the x first, so this would be negative x sine of x. Okay, so we have y prime. Now we could just put it into this equation. So y prime is cosine of x times, minus x sine of x equals the right side. So it's cosine x minus y tan of x, right? Uh, could we simplify the right side a bit? Yes. Tan of x is the same thing as sine x over cosine of x. Oh, I made a mistake. We do have to replace y with not y, but yes, we have to replace. Do you see this y right here? We're going to replace that with x cosine x. So it's x cosine x times tan of x, which is y over x, so sine of x over cosine of x. Then the cosine x cancels, so you're left with x sine of x. And now it's cosine of x minus x sine of x. Okay, so now we just verified it. So the left equals to the right, so we just verified it. Yeah, so as you can see, the left does equals the right, so we just verified it. Okay, so we did that one. Oh, we have to use our initial condition. We have to use the coordinates. So you're gonna need your trig. So we said that our initial conditions, well, we said our x is pi over 4, and my y is pi over 4 radical 2, right? So it's going to be cosine of x, which is pi over 4, minus x, which is pi over 4, times sine of x, which is pi over 4. So this is cosine of x, which is pi over 4, minus x, which is pi over 4, sine of x, which is okay. So no, actually, we don't have to do this. We got to find. So we got to step 3 is we got to verify the initial value. So if y equals x times cosine of x, and we have the conditions of y of pi fourth equals to pi over 4 radical 2, that means pi over 4 is your x, and then your y is pi over 4 radical 2. Okay, so we're going to replace y with pi over 4 radical 2 equals to x, which is pi over 4, times cosine of x, which is pi over 4. So that would be pi over 4. Cosine of pi over 4 is radical 2 over 2. And if you clean this up, this is uh, radical 2 pi over 8. And then on the left, it's pi over 4 radical 2. Now, on the left side, you can simplify it. Remember, you usually can't have a radical on the bottom, so you would rationalize top and bottom by radical 2. So this is radical 2 pi. Radical 2 times radical 2 is 2 times 4 is 8. So this is radical 2 pi over 8. Okay, so you just verified it. Okay, okay, let's move on to number 4. So number 4 says determine whether the uniqueness existence theorem applies to the given initial value problem. Initial value problem has a unique solution. Oh, I didn't write the answer. I mean the question. So we have a equals y prime equals 3x times y minus 1 to the 1/3, where y3 equals -7. Determine whether the uniqueness existence theorem implies that the given initial value problem has a unique solution. Okay, so what would I do? First, I would verify f of x comma y equals to y prime and is continuous at 3 comma negative 7, right? So what should I do? So mm, oh, you just plug in your points. If you get a real value, that means it's continuous. So it's going to be y prime, and then it's 3 times x, which is 3, and then my y value is negative 7 minus 1 to the 1/3. So that is 3 times 3 is 9, right? 3 times 3 is 9. Negative 7 minus 1 is negative 8 to the 1/3. Uh, if you put that in the calculator, you usually get a negative 18. So yes, this implies it's, yes, continuous. Then what we have to do is take the derivative in respect to y. Okay, so what you have to do is take the derivative in respect to y. So if you our function is this, what we're going to do. So okay, so if y prime equals to 3x times y minus 1 to the 1/3, right? And we got to take the derivative in respect to y. So this 3x does not have a y, so you could ignore it. So, or not ignore it, just bring it down, right? And then don't ignore it. Just bring it down because we're not going to take the derivative of 3x because it does not have a y. So now you just really just take the derivative of this. Do you apply the power rule? So it would be 1/3 y minus 1 and then old power minus 1. So 1/3 minus 1 or 3 over 3. So over here the 3's cancel. So you're left with x y minus 1 and then 1/3 minus 3 is negative 2/3. And then all you got to do is plug in your point, 3 comma negative 7. Here's your x, here's your y. My x is 3, my y is negative 7 minus 1 to the negative 2/3. So it's going to be 3, and then negative 7 minus 1 is negative 8 to the negative 2/3. So that is going to be, you put it all together, it's 3/4. So yes, it's continuous. And yes, it's a unique solution. Okay. Uh, last one, number 5. So number 5 says find the largest open interval on which a unique solution is defined. We have on A we have y third derivative or y triple prime plus square root of x minus 3 times y prime plus y equals the cosine of x, where you given a given initial value of y5 equals 1, y prime of 5 equals 1, and y double prime of 5 equals to 0. So first, I got to find the domain. So this is a square root graph. And how do you find the domain of a square root? You basically do whatever the square root set it to greater than equal to 0. So in our case, it would be square root of x minus 3 greater than equal to 0, and then solve for x. So you have to get rid of the radical by squaring both sides. So it's x minus 3 is greater than equal to 0. Add 3, add 3. You get x is greater than equal to 0. So what that means is the domain is from, whoops, why did it say 0? It's 3. The domain is bracket 3 to infinity, right? Because remember, square root, they include it. Now, it has to contain the point 5 comma 1, right? So how would we rewrite it if our domain is from bracket 3 to infinity, but includes the point 5 comma 1? I guess you're going to rewrite it as 3 to infinity, right? Because it's a dark circle, and then it has to include the point 5 comma 1. 3, 4, 5. Here's 5. So yeah, it's just going to be from 3 to infinity. So yeah, 5 comma 1 is in the domain of bracket 3 to infinity parentheses. So this would be the largest interval, parentheses 3 comma infinity parentheses. Okay. Yep, that wraps up for this quiz. So I'm going to stop here.